So hello and welcome back. Today we're going to be covering how to install our modular battery system for the Ninebot ES line of electric scooters. This battery system boasts quite a few advantages over the traditional official external battery system for the Ninebot ES scooters, which we'll get into in a sec. But for now, here's proof that we can swap the batteries in just about 18 seconds. Before we begin this project, I think it's important to mention that this project does involve some 3D printed parts, whose 3D files are available for free download in the Thingiverse link below. If you don't have a 3D printer, these parts are also available for purchase on eBay if you'd also like to support our channel. One final disclaimer here is that the steps performed in this video are actually quite difficult, and if you don't have any experience with any DIY projects or soldering, etc., this might not be the project for you, and you probably want to watch through the video before beginning this, just so you don't break your scooter. Okay, now let's go over some of the advantages of our modular battery system. For starters, the modular batteries are actually cheaper. Official external batteries generally run online between $120 new and to around $60 used. Since our modular battery system actually repurposes internal batteries, which still have the same capacity as official external batteries, but they actually only cost about $20 to $30 each, so you effectively save 50% on your batteries. Another advantage is that you can actually swap our modular batteries in roughly 18 seconds, as you saw earlier, whereas official external batteries, it actually involves removing 2 bolts and then removing the battery, which is very time consuming, and then you have to carry additional tools with you. Finally, the modular design of our battery mount allows you to carry additional batteries with you, which you can easily swap in for longer trips. The compact cylindrical design of internal batteries is also slightly smaller than the official external batteries, allowing you to carry more batteries. So before we actually start installing our modular external battery, I just want to quickly go over exactly what we're going to be doing in this tutorial and exactly why we have to do it. So what we're essentially going to be doing is wiring our modular external battery directly in parallel with our internal battery. And the reason we have to do this is you may be wondering like, hey, there's an official external battery port. Why don't we just wire our modular external battery directly into that? And the reason is you can actually wire in the power leads and you can even wire in the data and charge leads into that. And in fact, if you open the app, it'll even recognize it and read out the statistics of your modular external battery. But since your modular external battery is actually an internal battery, just repurposed externally, the speed controller will recognize that and actually read a battery error which cannot be bypassed. Because of that, what we're actually going to do is just wire that modular external battery in parallel with the internal battery. So to do that, we're going to have to essentially drill a hole in the side of your steering shaft tube and then just wire in the power wires and then charge wires from your external battery into your internal battery, such that the scooter only recognizes one battery when in fact there's actually 2. So let's get started. This project does require quite a few parts and tools, and for starters, let's just gather the parts we're actually going to install onto our scooter. You're going to need your modular external battery mounts, some 20 gauge silicone wire, some 16 to 18 gauge silicone wire, a male XT30 connector, 2 M4x8 bolts, 12 M3x6 knurled insert nuts, and 8 M3x16 bolts. You're of course also going to need an additional internal battery. And the final electronic part you're going to need is this funky connector here, and I for the life of me cannot find out what type of connector it is. If you know, please leave it in the comments below, but it can be salvaged either off of an old speed controller, and if you don't happen to have an old speed controller laying around, it can just be replaced with any 4-pin connector, such as this JST-XH. Okay, so just a quick update before we move on to the tools section here. Since we were having issues with modular external batteries ejecting at high speeds, we've since designed in these little red fingers which essentially slide over the slider slot mechanism and prevent the battery from flying out if you happen to hit a large bump. While the rest of the tutorial may not depict these fingers in every single scene, they are essential and will be included in the final version of these modular battery mounts. That means you will also need to tack on 2 M3x8 bolts under your parts list. Okay, on to tools. You're going to need some WD-40, pair of scissors, some solder, electrical tape, flush cutters, needle nose pliers, some medium strength thread locker, and some cable sleeving. You're also going to need a drill, some drill bits, specifically a 1/2 inch size. These should be capable of drilling through soft metal like aluminum, multi-purpose screwdriver set, a hot glue gun, a TS100 soldering iron or any other soldering iron. I really like the TS100 though. Some wire strippers, and some anti-tamper bits. Okay, now you have to install your battery sleeves, and to do this you just have to slide them over your battery, making sure that this NCE text faces the bottom of your battery where your wires are coming out. You want to slide them on so that the bolt hole on one side of your battery sleeves aligns with the bottommost nut on your battery, and then you're actually going to be installing 2 of these, so also one on the uppermost nut of your battery. And then once you have those in place and lined up, you can screw them in. Okay, now onto the actual mount part. So the mount is the part that actually screws onto your handlebar and holds your battery in place. To allow it to screw into the handlebar, we actually need to insert your M3x6 knurled brass insert nuts, and this is actually easily done using a soldering iron. So what you want to do is turn your mount upside down, like so, and then just rest one of your brass insert nuts at the top, heat up your soldering iron anywhere between 300 and 400 Celsius, and then gently push the nut in. Don't push it in all the way though, because once it's almost in, you want to quickly flip around your mount and then press the nut in the rest of the way on a table. This will ensure that the nut goes in straight and then it'll have a clean surface finish. So now that you've inserted all of your M3x6 brass insert nuts, it's time to use your hot glue gun and just kind of create 2 medium thick strips of hot glue inside the small notches of your mounts. What this does actually is it gives the mount traction so that over the course of riding, the vibrations on your scooter doesn't cause the mount to just slide down your handlebars. If possible, while the hot glue is still wet, you want to take your mount and then push that up against your steering shaft tube, and what that'll do is flatten out the hot glue to maximize contact. And then you want to repeat that process with the clamp, which is the other 3D printed part which mounts directly in front of your mount. Once the hot glue is dried, you can just take your external battery and just gently knock them off the steering shaft tube. Okay, so just a quick little blurb on how to install your safety fingers. So you want to take your M3x8 bolt, and you don't have to use them, but it helps reduce friction, and slide on a washer on your bolt, and then after that you can slide on your safety finger, and then slide on one last washer, and then add a tiny dot of medium strength thread locker to the end, and screw that assembly down into your upper knurled insert nuts. And you want to tighten them such that you can feel a little bit resistance, so just the vibrations of the road aren't going to cause your finger to move, but not too tight to the point where it's hard to move. And there you go. Now we can begin to start taking apart our scooter. So for starters, you're going to want to use either a hex bit or anti-tamper bit, depending on what your scooter has, to remove the 4 screws that hold the handlebars onto the steering shaft tube. After that, you can easily lift off the handlebar assembly and unplug the connector. After that, you're going to want to go to the bottom of the steering shaft tube and remove the 4 bolts which connect it to the lower deck section of your scooter. These bolts typically have anti-tamper heads, but I've replaced them with just regular hex bolts for ease of removal. These bolts can also be sometimes really tight, so it might be a good idea to use a drill or impact driver if you can't get them out by hand. Once you have all of those bolts out, you can set them aside and then gently lift off your steering shaft tube from the lower deck section of your scooter and begin to unplug all of the connectors connecting them. Once that is done, you can take your steering shaft tube and set it aside on a table with your battery sleeves, and mounts. Then take your battery mounts and slide them into your battery sleeves until you hear a click. Now take your battery and mount assembly and carefully position it on your steering shaft tube such that none of the mounts cover any of the bolts running up and down the length of your steering shaft tube. This is critical as you'll need to remove those bolts later. You also want to make sure that the bottom of the battery is facing the bottom of the steering shaft tube, meaning the side of the battery with the 2 wires coming out of it faces the side of the steering shaft tube where all those wires that you unplugged from the deck assembly are also facing. Once you have everything positioned as you like it, you can begin to install your clamps. So for these, you just want to press onto the other side and visually line up the bolt holes. Then you can begin to insert your M3x16 bolts and begin to tighten them. When you do this, it's really important that you maintain an even tension across all 4 bolts, as the uneven tension across the bolts will pull out the brass insert nuts you've inserted. I do this by gently tightening all 4 bolts on one mount and then going over and then tighten them a little bit tighter. And you want to keep tightening them right until you start seeing the brass insert nuts starting to get pulled out of their sockets, or it just feels super tight. So now it's time to test the slider slot mechanism on your modular battery. There's 2 ways to easily do this. Way 1 is just grabbing your modular battery firmly around the center and then pulling upwards. And then the second way is taking the palm of your hand and smacking the bottom of your modular external battery. And what that'll do is it should easily knock loose the bubble joints which hold it in place. If you can't seem to remove your modular battery with either of these methods, then you've likely printed a version of the mount which is too tight and you need to go over to Thingiverse and print a looser version. Take an anti-tamper or hex bit and remove the 3 flathead bolts that run the length of your steering shaft tube. Some Ninebot scooters have a cover over their charging port and official external battery port, and this cover can easily be removed with a flathead screwdriver. And once that is off, you can take a hex screwdriver and remove the 2 bolts which hold the other plastic cover in place, and lift that off to expose one final bolt, and you can now use a smaller hex bit to remove that bolt. Okay, so now we're at the trickiest part of this disassembly, and that's to remove the 2 plastic rings at either end of the steering shaft tube, which hold little rubber inserts in place to prevent water getting into the electronics inside. These have to be removed by pressing down and then rotating, And this can either be done with a pair of needle nose pliers, as I'm doing right here, or it can also be done with this handy dandy 3D printed tool we've designed, which allows you to apply even pressure across the plastic part and making the removal a lot easier. Once again, just like all the other 3D printed parts, they're all open source, and there's a link in the description below to download them, print them yourself. If you don't have a 3D printer or would like to support our channel, you can also purchase one from the eBay link below. If you're trying to use the plier technique, you really just have to give it patience. I've had it take me up to 20 minutes to actually get one of these out. It's a little tricky because with the pliers, you can't apply even pressure. Sometimes you can try to use 2 pliers, but it doesn't really seem to help. You also want to make sure you're rotating in the right direction, as if you look closely on the little plastic part here, the notches are orientated such they have to be rotated one way to be removed. And then once you've twisted them so that they can slide out, you just kind of want to pull them out with a pair of needle nose pliers. And you want to do this to both the top and bottom of the steering shaft tube. Once you have those out, you can take a wooden dowel or any other sort of rod and gently push out your electronics. Make sure you're pushing from the top down so you're pushing on your battery and not your speed controller, as it's really easy to damage your speed controller. Just a quick explanation on what you pulled out. The black part is the battery, and the silver part is the electronic speed controller, or ESC, also known as the control board. So these two parts are kind of held together with a little plastic spacer so they can be relatively easily separated. And when you're separating them, you want to make sure to carefully unplug the battery's power leads, which is that XT30 connector that's black, and the battery's data and charge connector as well, which is that funky connector, which we cannot find out what it is. Now that your ESC is separate from the battery, you want to kind of reach inside the ESC and unplug the red and black cable that is wired into the charge port on the side of the ESC. You want to make sure to take it out gently so you don't accidentally rip anything off the PCB. Now that you have that out, you can take another hex screwdriver and remove the 2 bolts holding the charge port in place, and then remove the charge port entirely. So what we're going to be doing in the following steps is drilling a hole in the side of the steering shaft tube, and that's going to allow us to run some wires out of the ESC to plug into our external battery, which we've mounted. So now that the charging port is removed, we're actually going to take our ESC and slide it back into our steering shaft tube, making sure that the wires face out the bottom just as we removed it, and we're going to slide it in right until we can take that final bolt we removed and screw that back in, and that's just going to hold our ESC in place while we drill the hole through the steering shaft tube and then through the ESC. Now we're going to get our 1/2-inch drill bit and stick that into our drill chuck. I think the easiest way to drill the hole here is to take your steering shaft tube and stick it in a vise and then tighten it lightly. Make sure not to over tighten it, as you'll actually deform the steering shaft tube and you won't be able to fit all the electronics back in again. Since the hole we will be drilling is going to be directly perpendicular to the charge port on the ESC, we want to make sure to mount our steering shaft tube in the vise accordingly. Since aluminum is such a soft metal, while drilling you want to make sure to regularly squirt little bits of WD-40 right under your drill bit such that you don't destroy your bit, because what will actually happen is the aluminum will just start to cake on to the tip of your bit and it'll make it dull pretty quickly. And if you happen to have a drill press, this is actually a lot easier and you'll just generally get a cleaner and straighter hole. And after you've been drilling for a while and you feel like your bit is about to approach the inside of the ESC, make sure to slow down a bit, because you don't want to be drilling super fast then accidentally shove your bit super far into the ESC and destroy a bunch of stuff in there. So be really careful while drilling here, such that when you finally do break through, it doesn't destroy everything inside the ESC. Once you've finished drilling, you can remove the bolt that we were using to hold the ESC in place, and then once that bolt is removed, you can take either a wooden dowel or any other sort of rod and try to gently push out the ESC, as the drilling process likely created a small flange between the steering shaft tube and the ESC, which could make it a little tricky to remove by hand. When pushing out the ESC, you want to be very careful with whatever rod you're using and to only tap the side of the ESC enclosure and not the actual PCB inside the ESC, as you'll easily damage the PCB. And once you've got your ESC removed from the steering shaft tube, I'd highly recommend using a paper towel or a rag and just getting some isopropyl alcohol and kind of wiping it down, and as well as inside the steering shaft tube, and possibly blowing it out with some compressed air, just as during the drilling process you likely created some aluminum shavings and you don't want those to short something out on your ESC once you reassemble it. So as I've mentioned before, the basis of this project is basically just taking another internal battery and wiring it in parallel with your original internal battery. So there's actually 2 ways to do that, and there's benefits to each one. So the first way is what I'm showing you here, and that is where you literally take your internal battery and you strip away parts of the wire and then solder directly onto the battery leads, your extensions, which will run outside of your steering shaft tube through that hole, and then into your external battery. The benefits of this are, it's not very challenging in terms of the soldering needed. There's no small solder joints or anything like that. However, it is a little sloppy and just generally not the cleanest way to do stuff. The other way you could wire your external battery in parallel with your internal battery is actually soldering wires directly to your speed controller like this. As you can see, this is a lot cleaner, though it does involve some soldering directly onto your speed controller, and for those with not much soldering experience, this probably isn't best for you. First, we're going to go over the way where you solder the wires directly to the internal battery, and then after that, we're going to go over how to solder them to the speed controller. I suggest you watch both, and then just decide what you want to do in the end. Take the internal battery that we just removed from our steering shaft tube, not the one with the battery sleeves we screwed in, but the one we just removed, and we're going to take the two power leads, and those are the two thicker wires coming out the bottom of the battery that connect to that black XT30 connector, and what we're going to do is we're going to take our wire strippers and carefully strip a short section from the center of each one and tin that, and what that's going to allow us to do is solder in our 18 gauge wire, which will then wire externally to our external battery. And while you're doing this, I can't put enough emphasis on how important it is to be very careful and only do one at a time, as if you do both, you'll actually create a short circuit between the two power leads and through your wire strippers, and you'll likely liquefy part of your wire strippers and sparks are going to fly. It'll be really bad. And when you're also doing this, you want to make sure you use the right hole on your wire strippers, as a too small hole will cause you to cut the power leads, and it's just going to make stuff very difficult. Because remember, you just want to strip and pull apart the silicon sleeve just a teeny bit so you can, put a little solder on there to solder on another wire. And once you have that small section stripped and tinned, you're going to want to strip a teeny bit off the tip of your red 18 gauge wire and then tin that as well. And then when you solder this on, you want to make sure the red wire is facing towards the battery, and this will make it a lot easier for you to install later onto the ESC. Also, you want to make sure that you're soldering your 18 gauge red wire to the red wire on the power leads and not vice versa, as if you wire two of these batteries with the reverse polarity, you're going to have a really big issue on your hands. And since we never fully cut through that red power lead wire, we're actually going to take a small section of electrical tape and wrap that around. And you want to make sure this electrical tape is super tight, and even possibly have the tape come together where the two adhesive sides are touching each other. That will make sure that it doesn't come off, because if this comes off, you're going to have a really gnarly internal fire later. So you want to make sure this electrical tape is very strong. And then you want to repeat that stripping and soldering procedure for your black 18 gauge wire as well. And just as one final measure to make sure our electrical tape doesn't fall off, I'm actually going to run a mini zip tie around each power lead. Okay, so moving on to the data/charge plug. So on the data/charge plug, the white and yellow wires are just data, TX and RX, and the black and red wires are charged. That's where you put in your 42 volts from your power supply to charge your electric scooter. And what we're going to do is take some flush cutters and just cut back this heat shrink here so we can access the positive and negative charge wires a little bit. And to solder onto these, instead of using wire strippers to access the middle core of the wire, we're actually just going to take the soldering iron, because instead of having a silicone sleeve, these actually just have a PVC sleeve, so you can easily burn through it with your soldering iron and then tin a small section. And then once we have our small section tinned, we're going to solder on our 20 gauge red and black wires, just as we did with our 18 gauge power wires. Okay, so on to wiring method number 2. So for this, you're going to have to remove the 3 flathead bolts on the back of your speed controller, and this is going to allow you to slide out your speed controller's PCB, which we're going to need to solder onto later. So you can kind of slide that out. Now once that is out, you can kind of measure out roughly, I would say, 8 to 10 inches of your 18 gauge silicone wire, and then cut that with a pair of flush cutters. And then strip a tiny bit off each end. And then, of course, tin those. And your speed controller likely has something called conformal coating the top of its PCB. It's basically like nail polish for electronics. It makes it a little more weather resistant and water resistant, but it also makes it harder to solder on to any terminals coated with it. So we're just actually going to take some solder and just lightly tin these 2 battery terminals on the top of our PCB here. And that's just going to burn away the conformal coating so we can solder on our 18 gauge wire. Make sure the red one goes to the positive and the black one goes to the negative. Now we can similarly strip and tin our thinner 20 gauge wire. And then we can flip our speed controller over, and we're going to be soldering our 20 gauge wire to the 2 solder joints that are part of our battery connector here that are furthest away from that aluminum heatsink block. So look at this diagram here. And when you're soldering these on, since they're very close, you want to make sure that you only have a tiny bit of the very end of your wire stripped. If there's too much, there's a chance of them crossing and then shorting out, which would not be good when you're charging and pumping 100 watts through them. So if there happens to be a little bit excess wire that's been stripped and tinned on the end, make sure to trim that down so it's only a millimeter or two. And once you've got those soldered on, you just want to give them a light tug and make sure they don't come off. If they do, you want to solder them back on and make sure it's a really secure joint so they don't fall off later with the vibrations of riding your scooter. And just to relieve some tension on our thinner charge wires, since their solder joints aren't very large and I can't imagine they're particularly strong, I'm going to run a mini zip tie around all 4 wires that we soldered to our speed controller's PCB, and that'll just kind of distribute the stress across all of them so that none of them get yanked off. Now everything is soldered to our speed controller, we can take our speed controller PCB and slide that back into the aluminum housing, and then push it in just till all the bolt holes align, and then you can take those 3 flathead bolts you removed earlier and screw those back in. Now take some small pieces of electrical tape and just cap the tips of all those wires we soldered in parallel. By that I mean the other ends that aren't soldered. And then once you're done capping each one, run a larger piece of electrical tape and group them all together. This is because we're going to have to run them through that hole we drilled in the side of our steering shaft tube, and then we're going to kind of have to stuff them back into our ESC before we can pull them out later. You'll see what I mean. Just stick the electrical tape on there. Now you can take the 2 small flathead bolts that you removed earlier and use that to reinstall your charge port, making sure that the small silicone gasket is on top of the charge port before it's screwed in, and that'll just ensure that it stays watertight. And then don't forget to plug in the charge port. Now we can go about carefully rewiring our battery back into our speed controller. So you're going to want to take that female XT30 and you want to plug that into the male XT30 port on the speed controller. And then you want to do the same thing with that charge plug. When you do this, you want to make sure both of these connectors are seated very well, as if they become unplugged in the process of installing your electronics, it's going to be a really big pain to get them plugged in again. And once those are plugged in, we can take the wires that we've soldered in parallel and kind of thread those through the hole we've drilled in the side of the ESC. When you finally take your internal battery and use that little plastic part to kind of snap it into your ESC, you want to make sure that the side of the internal battery with the bolt holes aligns with the side of the ESC with the charge port and the external battery port as well, because if you accidentally reverse your battery, you won't be able to later screw it in. The final step for this assembly process is taking the long wire coming out of your ESC that plugs into your dashboard and kind of pressing it into the notch that runs the length of the internal battery. Okay, it's finally time to start installing this bad boy. So for that, we're going to take those wires that are running out the hole we drilled in the side of the ESC, and we're going to kind of stuff those in there just so that the tip that we've electrical taped is right at the surface, but still inside of the hole, so we can easily pull that out with a pair of pliers later. And then once that's done, we're going to take our entire assembly here and slide that back into our steering shaft tube. And while you're doing this, make sure that you are always applying pressure to the ESC and you never turn it upside down, because once again, that'll cause the battery to kind of pull out and it'll unplug the connectors that you've plugged in, and then you'll have to slide it out again and reseat those connectors. When you're pushing in your battery and ESC assembly, make sure to do so slowly, and then just when your charge port on your ESC aligns with the charge port hole on your steering shaft tube, you want to stop pushing and then take that bolt that we keep on removing and sticking back in, and finally stick that in permanently. And once you have that ESC bolt in, you want to take your anti-tamper or hex screwdriver and then quickly put in one of the 3 flathead bolts that secure your internal battery in place, because once you have your ESC and internal battery secured, you don't have to worry about those connectors inside getting unplugged. And then you can screw in those other 2 flathead bolts that secure your internal battery in place and insert this little rubber plug into your official external battery port, and then install your charge port plug, and then you can put on the cover that holds both of those in place, and then screw in those 2 flathead bolts which holds the cover in place. Once those are in, you can take that final cover and that just snaps on. And now we can turn over our steering shaft tube and carefully use a pair of needle nose pliers to pull out those wires which we electrical taped together. And then we're going to stretch those out once again, and since they're at an angle, we're going to take our flush cutters and snip them individually once again so that they're all the same length. When doing this, if they're already super short, don't do this. This is just because I have some extra wire and I want them all to be nice and clean. And there we go, now our wires are out. Now we can take our hot glue gun and kind of plug up that hole. It's important that when you do this, the area around this hole on your steering shaft tube is nice and clean, otherwise the hot glue won't stick. If it's not, just take some isopropyl alcohol and wipe it off. So once your hot glue is fully cured, you can then take your 2 thicker 18 gauge wires and strip a tiny bit off the top, and we will be installing our male XT30 connector, which will connect to our external battery. And then tin those 2 wires. And for this step, you could either use heat shrink or you could use electrical tape. I'm just going to use heat shrink because I happen to have some around. So slide on some heat shrink onto your wires and then solder them on. And now we can repeat this process with our thinner 20 gauge wires, which we will be wiring on that funky charge connector. So the same thing, we're going to strip and tin those wires and then solder them together, and then either use heat shrink or electrical tape to insulate the connection. And when you're soldering on your charge/data connector, you want to make sure you're soldering onto the two wires that are for charging and not data. You can do this by simply plugging the connector into your external battery and just checking that it aligns with the red and black wires. Finally, we're going to take that cable sleeving that I had earlier. This is the type that you twist on. You could also use the type that you slide on. And this is totally optional. You can honestly just leave these wires separate, but I find that adding cable sleeving to hold them together just makes stuff a lot neater, especially since you're going to be kind of riding this around. You don't want it to get caught on anything, or you just want it to be kind of like a clean package. Now that we have all of our wiring done, we're going to reinsert our upper and lower steering shaft tube plugs. That's that plastic part and that weird rubber gasket thing. And once again, these can either be installed using pliers to retighten them, or of course you can use our handy plug remover tool, which is available for free download in the description below, or you can purchase it on eBay and support this channel. Okay, so once you have those two parts in, it's time to actually install our steering shaft tube back onto our deck assembly. So we're just going to kind of hold that in place while we plug in our motor wires, our hall sensor wires, and then our wires to power our LED strip and brake lights. When doing this, I like to try to keep my wires organized and just not have them in a giant ball. Once those are all connected, you can kind of stuff them back into the steering shaft tube and slide it back on. Make sure you're not accidentally pinching any wires. And then once that's done, you can take your 4 bolts, the 2 in the front and 2 in the back that you removed, and stick them back in. When doing this, I'm using a drill. Make sure that you have the drill clutch set accordingly. You don't want to accidentally strip your bolts, as you can actually sometimes even strip the threads which they go into, and that'll make it so you can never get them tight. We also highly recommend adding some medium strength blue thread locker to all of your bolts while doing this, just so that they don't rattle loose over time. Now you can plug your handlebar assembly into your steering shaft tube and then slide it on. And then screw in your 4 upper flathead bolts. And there you go, you've officially done all the steps needed to mount a modular external battery for your Ninebot ES scooter. So now before we move on and you decide to mount your battery and go ride it, I think it's important that we mention some of the safety and precautionary measures you should probably take now that you have this new modular external battery. For starters, since you still have an internal battery which can't be replaced, you must consider that if you drain your scooter empty and then swap in a fresh external battery, there will be a significant voltage difference between the internal and external batteries. The fresh external battery will discharge into the empty internal battery and balance the two batteries out, but will put the external battery under a lot of stress. Because of this, we don't recommend swapping in a fresh external battery and then riding your scooter if your internal battery is below 25%. If your internal battery is below 25%, then swap in an external battery and wait a couple of minutes for them to balance out. If you're using custom firmware or CFW, we highly suggest not using a motor power constant lower than 48,000. If you ever decide not to use an external battery and just remove your modular battery, using a motor power constant lower than 48,000 puts you at risk of damaging your internal battery's battery management circuit, or BMS. Additionally, if your internal battery is lower than your external battery is under the load of powering both your motor and also charging the internal battery all at once. A motor power constant lower than 48,000 will likely fry your modular battery management circuit if you try riding right after swapping in a fresh external battery. Okay, so now we have all that safety stuff out of the way, it's time to swap in our modular external battery and go for a ride. We hope you enjoyed this video, and we'll see you next time.